Okay, so now continuing, if we take the point slope form, and remember earlier we said that we had what we call the y-intercept, right? That's the point where a line crosses the y-axis. I'm sorry. Okay, that's the point where a line crosses the y-axis. And so at that point, your value of x is always going to be 0. And all they do is just substitute a variable b to represent that y coordinate. Okay, that's all. Okay, so if we take this point here and we plug it into the point slope form, we get y minus b equals the slope times x minus 0. Okay, so this is our point right here, and we call it point 1, x1, y1. Okay, x0, y represented by b. Okay, so now if we reduce this equation down, we get y minus b equals mx minus 0. Okay, that's gone, right? Subtract 0 out. Then you end up with y is equal to mx plus b. And guess what? That's the equation we talked about earlier called the slope-intercept form. I hope I called it the correct form, okay? Slope-intercept equation, or slope-intercept form, okay? Equation form, same thing. Don't get confused. A lot of times they call things different things and they don't tell you. But like I said, we're gonna understand math before it's over with, right? Okay. All right. So now there's another popular math equation. You don't normally run into this one, but I'm gonna just go over it real quick here and just derive it anyway. Okay. This equation is known as the two-intercept form, okay, and that's if you know the x-intercept and the y-intercept of a line, okay, and then you plug into that equation and find the equation of the line, okay. We're kind of going backwards here, deriving everything from the slope. So if we take this equation now, okay, and we plug in, we got the y-intercept, but guess what? An x-intercept is going to have a value of 0 in y and some value here for x. And so they kind of, cheat and call the this x-intercept, this x value, a. Okay, that's all. It's just a variable. You can call a variable, can be anything. Okay. A is the x-intercept, b is the y-intercept. So here, if we plug in for the slope, okay, we're going to kind of do something magical here. Okay, and I might have these backwards, so forgive me here. x2, y2. Okay, and I do have it upside down, but that's okay. Either way, it'll work out. So I'm gonna deviate from my notes, okay, so don't laugh. So we have 0 minus b over a minus 0, okay? And this reduces down to negative b over a, okay? Now, if we take this, plug in here, y equals negative b over a x plus b, okay? And our goal is to get both x and y on one side of the equation. Okay, that's just, you know, how they have that equation. Okay, so in this case we'll have b over ax plus y equals x over, if we divide through by b, okay, both sides of the equation, then we end up with x over a plus y over b equals b over b. Well, what is a number over itself reduced down to? 1. So we end up with x over a plus y over b equals 1. And guess what, y'all? That's your two-intercept equation, or that's what they call the two-intercept equation. Or it's in two-intercept form. Okay? And so this is my demonstration on how all the equations of lines are pretty much derived from the slope. So if you have a firm grasp of the slope, you're going to go places, all right, with the equations of lines. All right, so stay tuned for the next video, okay? Thanks.